Lesson 6-6, Perform Similarity Transformations. This lesson is an extension of Lesson 6-2 in more detail. I pretty much covered a lot of these vocab terms, but I would like you to review them once again. So a dilation is a transformation that stretches or shrinks a figure, and a center of dilation is the fixed point that a figure is enlarged or reduced around. Scale factor of a dilation is the ratio of a side length of the image to the corresponding length of the original. And a reduction is just when the scale factor is between 0 and 1, and an enlargement occurs when the scale factor is greater than 1. The coordinate notation for a dilation. So you can describe a dilation with respect to the origin with the notation xy to kx, ky, where k is the scale factor. So again, if you have a scale factor that's between 0 and 1, the dilation is a reduction. And if you have a scale factor that's greater than 1, the dilation is an enlargement. Example 1. Draw a dilation of quadrilateral ABCD with the vertices ABCD. Use a scale factor of half. So first of all, I've already drawn the vertices in and I connected the vertices to form the quadrilateral. Now I need to find the image, the coordinates of the new image by multiplying by half to the x and y coordinates of all 4 points. So I would do 2 times half, 0 times half, and this would give me 1, 0. Same thing, 6 times half, negative 4 times half, 3, negative 2, 8 times half. So the math here is pretty simple, but you just need to be careful with the details. 4, 1, and then 6 times half, 4 times half, and this will be 3, 3, 2. Now, I'm going to label all my points A prime, B prime, C prime, and D prime as mentioned in lesson 6-2. And now I'm ready to graph the new image. So at 1, 0, 3, negative 2. So this would be A prime, B prime, and then 4, 1, 2, 3, 4, 1, C prime, D prime. And I'm going to connect the dots and form the new image. Example 2, a triangle has the vertices A, 2, negative 1, B, 4, negative 1, and C, 4, 2. And the image of triangle ABC after a dilation with a scale factor of 2 is triangle DEF. So here we're going to have an enlargement because the scale factor is greater than 1. So in the last example, we had a reduction because the scale factor was half. Okay, so I'm going to take the points here, and instead of using A prime, D prime, B prime, C prime, you're going to use DEF. So I'm going to take 2 and multiply by 2. And negative 1 multiplied by 2. This will give me 4, negative 2. And again, 4 times 2, negative 1 times 2, 8, negative 2. Times 2, 2 times 2. 8, 4. And then again, I'm going to label my points. And go ahead and make this enlargement. Okay, where's 4? 1, 2, 3, 4, negative 2. So this would be my D and my E. 8, negative 2. This will be my E and my F. That's my F. can see this is an enlargement. Okay, now I need to verify that triangle ABC and triangle DEF are similar. So I can actually use the side similarity theorem. So for the sides, I could do AB to DE, AC to DF, and then CB to FE. So AB will be 2 units, DE will be 4 units, AC we're going to have, so by the Pythagorean theorem, if this were 2, 1, 2, 3, 9 plus 4, 13, take the square root of that, it's going to be square root of 13. And then DF, same thing, so this is 4, 6, square this, 16 plus 36, 52, so we'll take the square root of 52, and to find the length of DF, and then CB will be 3 units to 6 units, let's see. In this one, we can, so this one, I could do square root of 13 times 4, square root of 4. And this would be 2 square root of 13. I could cancel out square root of 13 to get half. So the ratios are all the same. Therefore, by side similarity theorem, these two triangles are similar. Example 3, Josie is making photo magnets. Her original photo is 8 inches by 10 inches. The image on the magnet is 2.8 inches by 3.5 inches. What is the scale factor of the reduction? So we can set up a proportion, 8 to 10. Actually, we could just simply write 8 to 10. And then draw an arrow and indicate that there's a reduction to 2.8 inches to 3.5 inches. And I am going to just either take the numerator or the denominator to calculate the scale factor. And I think the denominator is easier. So scale factor is represented by K. So I can go ahead and do 10K equals to 3.5. And then take 3.5, divide by 10, shift the decimal one place to the left, will give me 0.35. So that's your new scale factor. Example 4, part A, Mrs. Shooks wants to create a quadrilateral JKLM that is similar to quadrilateral PQRS. And what are the coordinates of M? So I've already delineated out or outlined all the points for you and match them up. So point J, 0,6 matches with 0,3, and point K to Q, point L to R. And I want to find out what the scale factor is. So by analyzing from point J to point P, I can tell from the y coordinate that the scale factor, well, this is an enlargement. So the scale factor must be a double, so 3 times 2 makes 6. And by judging from point K to Q, same thing, 2 to 4. You multiply by 2. And same for the x coordinate for L to R by 2. So I'm thinking that this point must be 0 must be multiplied by 2, but it's still 0. So the same goes for point P back to point J. So I have to take 5 here, each of these 5s, and multiply by 2 to get 10. 10. So that will be your point M. And for the next one, we do the same thing. You list out all the points and the corresponding ones. So Q to W. So for Q to W, it's 0, 5 to 0, 2. And then we can notice that from 0, 5 to 0, 2, when we look at the y coordinate especially, we can set 2k equal to 5. Scale factor. So 2 times 5 over 2 gives you the 5. So it seems like there's going to be a reduction here. So we're going to try the same thing for r to x with the x coordinate. So it seems like it's the same case. 2k equal to 5, k equals 5 over 2. And s to y, same thing. 2k equals to 5. You do it 2 times. So 5 over 2 seems to be the scale factor. So I could do the same thing for 4 and times 5 over 2 to get my x coordinate of 10 for point to t. And then 6 times 5 over 2 to get my y coordinate of 15. So your answer should be t equals 10, 15. So basically, when we are looking for a similar figure or the coordinate of a similar figure, we want to know whether the new quadrilateral in this case is a enlargement or a reduction by analyzing whether we can deduce what the scale factor is.